All right, great. I'm going to turn over the floor now to Kathy Perkins. She's the director of PhET Interactive Simulations at the University of Colorado, Boulder, and she's going to talk about PhET.
Great, thank you. Can you see my screen?
Sure can.
And is the Zoom window in the way, or is it okay?
Nope, we don't see the Zoom.
Awesome. Okay, so yeah, thank you for joining. So my focus is going to be a little bit more content specific to science and math and how PhET can provide a way to make science and math interactive, and it is an OER. So as we know, science is really an active process, right? It's about, it starts with curiosity about the way the world works, and it involves experimentation, interpretation, reasoning. So you really can't teach science very well without getting students involved in these practices and processes. And so one of the challenges for us is to make learning science more like doing science. So engaging students in those science inquiry practices, problem solving to advance their own knowledge and ideas through that engagement and exploration. And it's a similar challenge for any STEM discipline. And PhET is really, that's really one of its core goals, is to provide that environment in which students can engage in exploration and discovery, and to do that in a way where there is a lot of student agency, where it's connected to their everyday life, but where it uses some scaffolding, some affordances of the simulation feedback to make that exploration more intuitive and understandable, to develop students' understanding. So today, PhET has 161 simulations, 90 are in HTML5. We are continuing to bring more and more to HTML5. We started in 2002, so Java and Flash were the technology of the day then, so it's a big backlog of work for us. We have 3,000 sim-based lessons that are also open educational resources, shared, developed and shared by the community. We do have coverage across the different science and math disciplines, but physics, chemistry, and math are our main focus areas right now. We'd love to expand more into biology and earth science as funding allows. We do support translation, so they are in 90 languages, and we support online or offline use. This is just to give you a sense of the scale of PhET use. So it's 250 million sim runs per year now. And you can see a big increase as students and teachers had to teach remotely last year due to COVID, or last year and some this year. You really can't understand PhET without seeing some PhET sims. So I'm just going to give a super brief tour of some. So this is our energy skate park, where you have a skater and you can place her wherever you want to. There's different representations, so you can explore placing her in different places, adding friction, seeing what that does to the energy distribution here, changing gravity. This sim scaffolds over to the possibility of taking measurements. So you have a measurement tool here. You can, again, vary anything like friction or gravity, change the mass of the skater. Different screens scaffold to different types of experiences. So here's a different kind of graph that students can explore and develop understanding around. And then lots of times there's more of a playground version where students can build their own tracks. So that's a really popular one, energy skate park. This is another popular one, gas properties, where here we're showing sort of what a gas looks like from the microscopic level. You can heat the gas and see the particles start moving faster. You can change the size of the box and take data around pressure and temperature and the impacts of that. And you can explore kind of the idea of pressure by looking and taking data around wall collisions and changing pressure. And again, this scaffolds up to different ideas where you can explore work and energy, and then diffusion in the third screen. So that gives you a brief sense of what the simulations look like and how flexible they are. They really are designed to be super flexible tools that faculty, educational, instructional designers can adapt to their use. So they're designed to support multiple learning goals, from content goals to process goals, to being a tool where you can build collaboration, discussion, argumentation. Students can solve problems. And they also have a goal around making science and math more enjoyable and understandable for students. So high quality with high flexibility, I would say, is a theme for us. You'll see PhET simulations used in lecture tutorial, turning the lecture into not a lecture, integrated into activities and labs, and assigned as pre-lab, pre-class, and pre-homework activities. If you look at how PhET sims can integrate, for instance, into an introductory physics class, you'll see, there's sims that cover a lot of the content area. We're always making new sims, but we do have a lot already. And then you can, as an instructional designer, you can think about how to integrate that sim into the course, whether you want it to be in lecture or homework, in the textbook, whatever it is that you're creating. So I wanted to give you a flavor of what teaching with PhET sims looks like. You can really think of it as a spectrum, from where you have more teacher control of the simulation to where you have more student control of the simulation. Really, to engage students in STEM practices, it's better to be over here where we have more student control, where the students are interacting with the simulation. There's sort of an in-between where the faculty member is controlling the simulation, but you have interactive demos or concept questions, clicker questions for those familiar with Eric Mazur's peer instruction pedagogy, and then straight up using them as lecture or like supplements to lecture videos. So if you're creating video-based open educational resources, you might use the PhET simulation to provide a much more dynamic visual than you can otherwise create. So some top tips pedagogical wise for using PhET. One would be to start with open exploration. If you're creating an activity for students to engage in, don't start with telling students how to use the simulation, just have them play with it. They're super intuitive. We test every simulation with individual students, making sure that they lean into that engagement, that they ask questions, that they can use the feedback provided the simulation to start down the learning process of their development. So definitely open exploration questions give that ownership over to the student and the agency. And then the other key pedagogical tip is to use challenge prompts. So rather than direct instruction, to give students an open prompt. So we will see activities submitted to our website, that have very specific instructions: set the cannon to 45 degrees, measure the distance for these 3 initial speeds, and then graph. But you could rewrite the challenge prompt in a way that provides the ownership much more, turns the exploration ownership back to the student. What are all the ways to affect projectile distance? And so here the student can go in, take data, explore as a scientist, and collect the evidence that they need to justify their reasoning that they discover through that exploration. On our website, you'll find different teacher resources that can help you in the instructional design, or that you could use with faculty that you're training to talk about how to build lessons around PhET simulations. These are just some example challenge prompts. There's also the idea of the interactive concept questions. So I'm not going to go through this one, but the idea is you build a question, you have multiple choice answers. Again, this is based on Eric Mazur's peer discussion approach, where you prompt students with a question, they discuss with each other, they vote. And the PhET sim, in this case, can be the tool within which you conduct the experiment. So it is the source of the answer, essentially, and then the students can discuss that. You can also embed the simulations into, say, a textbook. So you can interleave sort of the text with these inquiry prompts, where you embed the simulation and you ask students to explore what would make these blocks float and why. So thinking about PhET as an OER resource, so the simulations themselves are not super revisable, I would say. they hit all the 5 R's except for revisable. We do have our source code up on GitHub and it is open source, but the complexity of the source code is such that we don't really encourage people to revise the simulations themselves, because oftentimes that will just branch the simulation, and then you know, Apple or Google or somebody will make a code change that will break the simulation. And so once it's branched, it's hard to fix. So we encourage people just to maintain it, and we try to provide a lot of flexibility in how we design the simulation. So it can be, you can design a lot of different activities around it. So when you think about sim-based learning, there's the sim, but then there's the activity task, there's the teacher facilitation, and that's where we see a lot of the revise and remix happening within the open space and PhET simulations. And it and exactly what that looks like depends on the context. So we have the design of the student and teacher and activity space that can be customized or adapted for student grade level, the teacher's learning goals, you know, their pedagogical approaches. You have the learning context, whether it's high school, higher ed, is it online, offline, you know, a large lecture. And then there's the devices that are available in the physical classroom. We also provide adaptivity for our language or the environment and community, for instance, different options for the UK versus US. So each sim can be translated at our website. That's open. You just write to us and ask to be a translator. And then there's this lesson data exchange database that I mentioned. So I just want to hop over to the website and show a few things. So the easiest place to start at PhET is to look at the all simulations. We have it filtered on HTML5 because those are the ones that are embeddable. There's these different filter categories for different subjects to find the simulations you want. We have a large project working on making these interactive tools accessible with a whole host of inclusive features. It is a research project. They're highly interactive tools. So there, you know, there's not standards basically that are well defined for how you do this for something so interactive. So we're basically innovating new ways to support screen readers for something that's so interactive, and how you can create the same kind of experience for non-visual students or low vision students. And you can see sort of what's available in that, where we're kind of at in that process by clicking on any one of these filters. If you click into a simulation itself, what you'll find is just you can run the simulation right from here. If you want to embed the simulation, here's the embed code. It's just simply a simple iframe. It's just a few lines of code will allow you to embed this in any, you know, any HTML5 page, and you can set your width and height, and the simulation will rescale for that. There's some resources down here, just learning goals topics, teacher resources we've created, tips for teachers, get you started. Not really intended for students, more for the teachers. Here's the activity exchange database, so you can find all the activities that are written around a particular sim with different filters. So those can get faculty, instructional designers started. You also find the translations here. All right. We do have a bunch of partners within the OER space that we already collaborate with. You'll find the FET sims on OER Commons. You'll find them in OpenStax. You'll find them on Hippocampus. They're integrated into GoLab. They're pretty easy to integrate. We also have a metadata service for other groups interested in integrating the simulations. Like we just partnered with Kuriki. They should be integrating the simulations soon. Some how-tos. So you want to look for HTML5. That's your best bet. Java is hard for students to run, although faculty can run it. Flash is now completely not an option, although we do still show them on our website. You can download the Swift file and run it, but I don't recommend it. We do have this new technology called Java with ChirpJ, which allows the simulations to run in the browser. So for our older simulations that aren't yet converted to HTML5, that provides a lifeline. For providing students access, you can provide them access to the sim page. You can provide them a direct link to the simulation itself. There are also ways to embed simulations into lots of different tools you already probably use. OneNote, Canvas, Moodle, Formative, or to deliver the simulation, basically by just downloading the file and uploading it to your LMS. It's really just all one packaged HTML file. There's no need for multiple HTML files. We also provide some query parameters that you can add on to the end of the simulation. So if you want to use just one screen, you can do that. So here's the Beers Law Lab simulation, has 2 screens, but let's say for your instructional design, you just want students to access the second screen. In any one of our HTML5 simulations, you can add on the screens equals parameter. In this case, that's the second screen I want, so screens equals 2. It will come up with just that one screen. So you can leverage that to scaffold students to the moment you want them to experience right then. There's also a screenshot. You can save a screenshot from this. There's a whole bunch of teacher resources you can find on our website. I'll let you go look around at those. I wanted to thank our funders because we are really reliant on them. And then invite you to check out the FET website more, look around, contribute lessons if you build them, and provide time for answering questions or more demos or whatever else you'd like.
Thank you so much, Kathy. That was great. Really good overview. Do we have any questions?
I didn't have a question, Kathy, but I did follow up while you were presenting on embedding FET and hypothesis annotations. And no, it's not possible yet. I'm sorry to report. One can obviously link to them, which isn't really so great, right? But
Right.
I am following up with our team to at least get it on our radar to support FET embeds as well.
Great. And
that'd be great. And I think I've seen FET and H5P linked together already. Do we plan to add statistics? Yes, I actually just wrote a grant to do that. So it takes a while to build FET sims, but hopefully we'll have sort of our first real statistics sim maybe next summer. It's going to be not at the necessarily college level, about mean and median. We do have some statistics sim already up there. Just look around. There's like least squares regression. There's a few. Curve fitting can sort of be linked to statistics. How does error impact your curve? There's also Plinko probability is up there as well. So there's the smattering of statistics.
Super. It's great. Any other questions for Kathy? Great. Well, thank you so much for your presentation. I think this was great. I feel like FET is still one of those things that not a lot of people have heard about yet in the OER community. So I'm glad we could share that with everyone and support our folks that are working in STEM.
I would mention that while we're known for science, we do have quite an extensive collection of math sims that would be appropriate for developmental math. About functions, graphing, just in some of the more fundamental concepts around fractions and things like that. So definitely provides a different, more interactive way of learning math that might benefit students who are in developmental math when they get to college. Great,
thank you for that. All right, great. So that concludes our presentations for today. Thanks, Lara. Did anyone else want to ask any other questions or talk about any next steps?
I bet everyone's brains are really full after all that.
Yeah.
my mind is reeling.
No, so many great things we can do. If only we had all the time in the world, right?
Yeah.
I think it's really exciting because when I first started working in OER like 8 years ago, it was like, let's just get people to swap their textbook, right? And it's just like, here's a text that's online and free and versus the text that's a book. And now there's so many great things that you can do to enhance that for learning and teaching and learning. And it's just growing and growing exponentially. So I find it extremely exciting.
Monica, have you had a visit from like the education folks at Creative Commons?
We have in fact, yeah. And for all of those folks who are members of the various compact, we do actually have a contract with Creative Commons to provide 15% off all of their professional learning. So I'll take this opportunity to promote that. You can find that contract on MEC's website. And it does add up quick if you have lots of folks you're sending through for training purposes, and they have amazing professional learning opportunities. Thank you, Kathy, for sharing the link to your presentation.
Yeah, I think that's should give a PDF link to the slides.
Awesome.
Possibly a slightly different order than the actual.
It's all good. It's all good. All right. Any other questions or thoughts from the group? Okay, well, thanks everyone for hanging in. We will see everyone on our next meeting is November 4th at 3 o'clock Central Time. That'll be just an hour. We will use that time to talk about all of the great presentations that we've heard over the course of the last several months and think about what we can continue to do as a working group to promote different technologies as they relate to OER. So I look forward to seeing as many of you as possible then and having a great conversation. Thank you all so much. Thanks to all our presenters for being here with us. We really appreciate it. All right. Thanks, everyone.
Thank you all. Have a great afternoon or evening.
Bye.
Bye.